Welcome to today's video. Today's video we're focusing on the quiz on systems of linear inequalities. I'm not going to go over the whole quiz with you, but I do want to talk about two problems that were on it. And there was quite a few mistakes. Although we did fairly well, we want to make sure we correct those mistakes so we don't have that happen in the future. The first one we want to look at, this was question number 2 on the quiz. And it's asking you to select all ordered pairs that are solutions to the following systems of inequalities. Now, in order for the coordinate pair to be a solution, it has to make true statements for both the inequalities, not just one, but both of them. I'm going to start with -1, 1, and I'm going to do this the algebraic way. I'm going to plug it in. So I'm going to take 2 times -1, since that's my x, minus my y is +1, and I want to see if that's greater than or equal to -3. Well, 2 times -1 is -2, minus 1 is -3. Well, is -3 greater than or equal to -3? It's equal to, so that works. So now I have to check the second one. My x is -1 plus my y is greater than -3. Well, -1 plus 1 is 0. Is 0 greater than -3? It is, so letter A works. Now we're going to check letter B. We have 0, -4. Again, I'm going to start with my first one. 2 times 0 minus -4 is greater than or equal to -3. Be careful. I know it says -4, but it's minus y. That's like multiplying it by a -1. So we can put that there to remind ourselves, but don't just drop one of the negative signs because. 2 times 0 is 0. -1 times -4 is +4. We want to know, is that greater than or equal to 3? Well, yeah, it's greater than. So now let's check our second one. 0 plus -4 is greater than -3. Well, that gives me -4 is greater than -3. -4 is definitely not greater, so since it doesn't work, B does not work. If I check letter C, I have 1, 0. Well, 2 times 1 minus 0 is greater than or equal to -3. Well, 2 times 1 is 2. 2 is definitely greater than or equal to -3. So now I'm going to check the bottom. I'm going to say 1 plus 0 is greater than -3. 1 plus 0 is 1. Well, 1 is definitely greater than -3. So since, and I apologize for the bell, since both of those statements work, letter C is also an answer. If we check D, we get -2, -1. Well, 2 times -2 minus, we're going to say -1 times -1 is greater than or equal to -3. 2 times -2 is -4. -1 times -1 is +1. Well, -4 plus 1 is -3. And -3 is equal to -3, so that works. Now I'm going to take my -2 plus my -1, and we want to know, is that greater than -3? Well, this becomes -3. In this case, it's saying -3 is greater than -3. Well, they're not greater than each other. They equal. So because that does not work, letter D is out. The last one we want to check is point E. We have 3, -2. Well, that means I could do 2 times 3 minus, we're going to call it -1, 2, and we want to know, is that greater than or equal to -3? Well, 2 times 3 is 6. -1 and -2 make +2, and 6 plus 2 is 8. That is definitely greater than -3, so we have to check our second one. We have 3 plus -2. We want to know, is that bigger than -3? Well, 3 minus 2 is 1, and 1 is greater than -3, so it does work. Please make sure when you have algebraic inequalities to solve with ordered pairs, please make sure you check all the points. Don't stop because you found one. Don't stop at the first inequality if it works. Make sure you check both. They both have to be true statements. Now, the second problem we want to look at. This was, and I believe it was number 4. If we look, we want to know which graph shows the correct solution to the following systems of inequalities. Well, if I look at my system, they're both in slope-intercept form, so that tells me I can graph these. So I'm going to start with my first one. I have a y-intercept of +2, so I'm going to start there. My slope is 3 over 2. They're both positive, so I'm going to go up 3 to the right 2, up 3 to the right 2, as many times as I can. Then I'm going to go down 3 to the left 2. 1, 2, 3. And again, we're doing this as many times as we can. Now, if I look, the sign's greater than or equal to. Because it has that equal to, we're going to make our solid line. Now, for shading, if it's greater than, I'm starting at my y-intercept, and I'm going above it. So I want to shade everything on that side of the line. I apologize for the bells keep going off. This is what happens when you record during the school day. Now, if you used a yellow highlighter like I did, when you go to your second equation, please don't use another yellow highlighter. Make sure you use either a pen or pencil or a different color highlighter. If you use pencil for the first equation, please don't use pencil again for the second one unless it's two different colored pencils. We want to make sure we can really tell where that overlay is. Now, for the next one, it's -3 is our y-intercept, and I have a slope of -1. So I'm going to make it a fraction of -1 over +1. So I go down 1 to the right 1, down 1 to the right 1, and then I'm going to go up 1 to the left 1. And I'm going to keep going as many times as I can. This case, it's a dashed line. There is no equal to. Now again, if you use yellow highlighter, pick a different color. If you use pencil, grab a highlighter. We need to make sure we can see where the different areas are. And I have a feeling that most of you, that's where you made the mistake when you were graphing, if you made a mistake, was you were able to graph the slope-intercept correctly, but you were unsure of your shaded area because of the same color pencil. Now it says y is less than, so it's going to be all this area down here. Now, this question was a multiple choice question, and I know I don't have the 4 answers posted on the board, but it asked which area shows our solution. Well, if I look, I used a yellow highlighter, I used a purple highlighter, so my solution area is the area that is shaded here in red. That is the only solution area that we have. The yellow does not count, it's not an overlap. The pink or purple doesn't count because it's not an overlap. Only the red is our solution area because that is the only place where both inequalities are intersecting each other simultaneously. If you have any other questions on the quiz, please feel free to come ask. Hopefully you feel more comfortable, you realized your mistakes if you made some. If you would like to retake the quiz after this, please come see us and we can work something out for you. Have a wonderful day.